Sometimes life takes unexpected turns in a blink of an eye. And then we face a test of character and resilience. And now I'd like to introduce to you some extraordinary people that will show you how far grit and imagination can take some of us. Let's see the video.
In 2008, I was at the top of my career, and I had a wreck during a competition, and I knew it was bad. It was a compound fracture in my left leg. After a few surgeries, doctors basically told me, we've got a tough decision here. We think it's best to amputate your leg just above the knee in order to save your life. You know, we kind of thought to ourselves, I'm like, now what? I mean, I'm a professional athlete, and I just had my leg amputated. I've always been a problem solver, worked in the shop trying to figure out how things work, and what better thing to focus on than my leg. I started drawing a design, and then figured I had what I needed, and went out to the shop and started cutting parts. And about a week later, I had the first prototype Moto knee. And I tell you what, I was like a little kid. I was so excited. At that point, I knew that, you know, this is really gonna work. I'm gonna be able to get out and ride like I normally did.
Please join me in welcoming Paralympic gold and silver medalist, 10 times X Games gold medalist, founder and inventor of Biodapt, Monster Mike Schultz.
Oh, thank you so much. Good morning, everybody. So this is my first time here at the SolidWorks conference convention, and I gotta say, impressive. There's so much cool stuff happening in this industry right here, right now. Like, seriously.
Like, why do they call you Monster? It doesn't look to me a monster. You know?
Well, I got a pretty mean face. Now, it actually came from my snowmobile racing days. I had a real aggressive riding style, like always up over the handlebars, you know, just grit my teeth. My wife says it's because I like cookies so much, but, you know.
Okay, so in the video you said something very interesting. Somehow you had the power of imagination. You said, I understood, I got it. It was going to work. How could you say that? What happened after that?
Man, like so much has happened since that day in 2008 when the doctor told me that we were gonna have to amputate my leg. You know, it could have consumed me, but right at that moment, I decided, I chose to try and look forward. And, you know, I wanted to make something positive happen out of something so negative. And so I just chose to look forward and fast forward a bit to when I realized that nobody created the equipment that would allow me to get back into the things that I loved the most, like motocross. I went to work and I started designing myself a better leg. And 4 months after the injury happened, I had my first Moto knee.
4 months.
4 months. Got back on the motocross bike. 7 months after the injury happened, I'm racing on the world stage, Summer X Games Adaptive Supercross. I got a silver medal on a leg I built in my garage.
Amazing.
Pretty wild.
Amazing.
Thank you. And that first summer, I realized what I had been working on was going to help so many others. And so in 2010, I started my company Biodapt with the intent of designing the highest performance lower limb prosthetic equipment. And right now, we've got customers all over the world, ranging from your everyday amputees who just want to get out and do more, to a ton of different veterans getting back in the gym, getting fit, and enjoying life, snowboarding, skiing, stuff like that. And a lot of athletes from around the world, some of which are my direct competitors on the race course.
Oh, wow. Amazing. So tell us what is so amazing in your design? What is your design process, and what is so specific on these high-performance prosthetics?
Yeah, so basically, there's some really good stuff for everyday equipment for walk around like I got right now. And, the fundamental difference is, thank you. So this one swings as I walk. And this one actually has spring resistance in it that helps it extend, like my quadricep muscles. So this system is designed around a Fox mountain bike shock. It's got compressed air in there and hydraulic dampening, and it's all tunable, so I can get on the snowboard, on the motocross bike, and I can tune it all. And what's really unique about this specific design compared to any other sport legs is this linkage system that I came up with that allows it to have full range of motion and a lot of resistance and alignment options.
That's amazing. So, but this was designed by you for you. But your dream now is to scale up and to empower many, many more athletes with this type of devices. How do you scale up? How do you go into scale?
Yeah, that was the tricky part because, I had a 9th grade drafting class experience. And so the original designs were all hand-drawn, pencil paper, rulers, protractors, lots of eraser. That, yeah, thank you. It still happens that way. But, I wanted to make it better for others and more manufacturable. So that's when I got introduced to Jesse and Mark from Center for Advanced Designs. I started working with them before that was CAD, but yeah, they really helped bring my hand drawings into 3D models with SolidWorks.
Okay, so let's get Jesse and Mark on stage. Please welcome Jesse and Mark of CAD, Center for Advanced Design. Hi, Jesse. Thank you to see you again.
Great to see you.
Thank you, Mark.
How are you doing?
Very good. These are all friends. We meet every now and then to dream about the future of design. So, welcome. Tell us what you do at CAD.
Yeah, for sure. So it all started about 10 years ago. Mark and I created a design firm called CAD, stands for Center for Advanced Design, and we're based out of Minneapolis. And we carved out a niche for ourselves, creating complex surface geometry for the plastics industry.
Yeah, CAD, we use SolidWorks to develop over 1,800 products that are on store shelves and in catalogs all over the world. We design mainly for the marine, power sports, consumer products, and medical device industries.
Yeah, and we got hooked up with Mike. So I grew up racing snowcross and motocross, not at the pro level like Mike. So I obviously knew who he was, but a mutual friend made the connection, and we just jumped at the opportunity to work with him. It's been almost 8 years now.
Long time.
It's a pretty unique relationship when we're in the conference room going over a design review during the week, and then I go home and turn on my TV and watch him live on X Games competing.
Yes, so. Amazing. So a collaboration lasted 8 years now. That's amazing. Tell us, how did your design thinking evolve in those years? Yeah, tell us about that.
Absolutely. So we're constantly evolving, constantly working. We're working on the next generation called the VF2, and a cool thing about that is we're actually building them here today. Sure. You're going to be able to see them being machined live in the shop floor in the playground today.
Oh, really? In the playground? Fantastic. Yeah. Very good.
We also have been leveraging X-Shape and X-Design to create a new cover for his everyday prosthetic that carries the look and the feel of his competition leg. It's kind of a...
Yeah, check this out. Check this out. Yeah, look at this guy.
Wow, wow.
So this is a cover for my everyday leg. But the best part right here.
Yeah.
Yeah, check that out. We gotta.
It's showing you. Yeah, there you go.
I'm a fan of Iron Man, so it had inspiration from Iron Man and my Moto knee. So awesome technology.
So we enter in the era of augmented superpowers. You know, these guys are amazing. So what I see there is very interesting. I see X-Shape there, 3D Creator. Tell us about that.
Yeah, sure. The 3D sculptor inside X-Shape is amazing. It was just a perfect opportunity to leverage that tool for a complex form like this. And yeah, we're actually using it to jumpstart a lot of the projects that we're working on at CAD.
Oh, really? Was it good to use these things?
Yes, yeah.
Was it an evolution with respect to the past?
Yeah, it's nice because we can focus on the proportions and finesse it as we go. And then it was a great way to quickly get it into a 3D form that I could share with Mike, and we could start iterating back and forth.
Now I have a $1 million question. backstage we were discussing your design practice, and you told me that you were using sensors to understand the stress and the strain of the device under big forces during competition. And I was wondering if you are thinking about making sensors and electronics permanent part of your design, of your prosthetics.
Yes, that is definitely a long-term dream for my company, Biodapt, and that would allow me as an amputee to have more control over my prosthesis. So, that's where the evolution is headed. So it's going to be exciting here in the future.
Very good, very good. So now I want to invite on stage someone that can help you there. I'm very pleased to have here an old friend, a very strong and knowledgeable user of SolidWorks, a PhD of the MIT Center for Biomechatronics, part of the Media Lab at MIT, Dr. Matt Kearney. Hi, Matt.
Hello.
Thank you for being here. I was showing the amazing videos of your robots, of your crawling robots a few years back. So you have been with us for many years, and you've been inspiring us, and you are really working to explore the future of what is possible, how to extend the human capabilities using technology. So tell us, what is the future of prosthetic design?
Yeah, I mean, that's the whole case right now, is we're trying to go to personalized bionics. So it's not just one robot system, or not even just a passive system, but it's a system that actually has full biological range of motion and power capabilities. So this system you see here is my PhD work. I actually took walking data from about 1,000 different gait cycles, fed it into a simulation of the actuators, and spit out component specifications that I then did a search across to find the absolute optimal combination to have minimum energy while still achieving all the performance requirements we wanted. I then did a whole packaging study in SolidWorks and modeled up this entire thing and had it built up. And so you can swap out the springs on the system, so you can tune it to individual users. And it's also a knee and an ankle. So it just goes next generation. So how do we actually achieve full biological capabilities and even have a neural interface, so you can have direct control of the system, so it becomes an extension of your body.
Oh man, how long before I can test that guy out on the motocross bike? Could we plug that something into my moto knee?
I have wondered if you could just put a motor on the end of it, you could just jump start it that way or something like that. I mean, there's all kinds of things we can do, right? Because it's a piece of hardware that you can upgrade as you go. You can change everything out. It's just another tool for you. But as it is, you can come in and you can try this thing. I'd love to get you on it. I think we'll show in a minute. There's also a knee system that's basically the exact same actuator. You just flip it upside down. It's not quite ready for the motocross. And that's the thing, it's one thing to do something in the research lab. It's another thing to actually get it out into the ruggedized environment.
It's amazing. So machines that connect to your brains to extend your capabilities, truly superpower. So actually, it is our intention, and this is what we are doing, to put in the platform the ability to simulate all of that and to connect all of that and to help you design all of this, because I know that this is part of your character, to share these amazing ideas with the rest of the world. So what do you think of our plan to put all of this together in a single platform?
Yeah, I mean, I think it's all about streamlining this process and just having one application where I can bring in my simulation ideally all the way from this gait simulation all the way into how the actuator is behaving. That I can tie in stress simulations, thermal simulations, and tie electronics into the package, and then be able to share those ideas with other players on the team. So that, right now, this is all one person doing it, but to really get this out to the environment, it's going to be a much larger team of people that are really ruggedizing the thing.
So, Dr. Kearney, what's next for you now?
Well, that's the thing, is how do I get this out of the laboratory? Okay. And I'm really excited to meet you guys, because this it fits right in.
That would look awesome as part of the moto knee. Get some wires and antennas and batteries. And
these guys are already working together.
Yeah, I mean, that's the name of the game, right? This thing has a very strong aesthetic. This is a very aggressive aesthetic with this system. This is a robot, and acknowledge that it's a robot, then we can go full bore with it.
Okay.
So, there we go.
Okay. You just said robots are awesome. I want to be one day. I'm halfway there.
Everyone will be.
This is amazing. They're already working together. See the chemistry that we create here on stage. Tell you what, next year, we'll have these gentlemen again on stage and check what's the status of augmented life prosthetic connected to the brain. Truly amazing. Gentlemen, thank you for showing us
Thank you, GP.
Thank you, Mike. Thank you. Mike, thank you. Matt, Jesse.
5. All right.
Yeah, thank you. Thank you, guys. Thank you. You see here, you have seen the future, you see the present, you see dreams coming true, you see the imagination of people. This is why it's so important for technology to stay human, because it is the human experience that counts.